Ladies and gentlemen, welcome back to another episode of Research Methods Awesome Knowledge Gaining Stuff. Title changes every time. Anyway, today I have a very special guest. The man goes by the name of Dougie Pete. Dougie Pete, why don't you introduce yourself?
Hi, the name's Dougie Pete. Pleasure to be here.
You want to, explain anything about yourself?
I am a motivational speaker.
Okay. Why are you here?
I don't know.
Okay. Great. All right, so today we're going to be talking about the scientific method and what is our biggest nemesis in psychology.
Confirmation bias.
Yeah, that's right. And why is that?
How might it affect your ability to be a therapist?
Are you just reading the words?
No.
Okay. Yeah, confirmation bias. So what is it? It's the idea that we seek evidence that confirms our existing opinions.
Yeah, that's what I was going to say.
Sure you were. All right, so why is that a nemesis in psychology? Because anytime you do an experiment, it's very easy to find evidence that confirms your hypothesis. And as a therapist, if you are working with clients and you have confirmation bias, you might think that they have a particular illness that they may not actually have, and yet you're going to find evidence that they actually have it. That's a problem.
Yeah, big problem.
Thank you. You're really contributing quite a bit here.
I know.
All right, so operational definitions. Mr. Pete, you want to take this one?
Yeah, sure. Operational definitions. What they are is they identify one or more specific observable events or conditions such that any other researcher can independently measure and or test for them. Okay? Any other researcher can independently test and or measure for them.
Wow, I saw how you did that. You flipped the measure and test so you can emphasize stuff.
Yeah, I'm a motivational speaker.
Clearly. You want to continue?
Yeah. So, what is the definition of late? Anyone?
They can't hear you.
I know.
Are you expecting a response?
No.
Okay.
So, what is the definition of late?
You want me to take this?
Yeah, if you could, please.
Oh, okay. So, definition of late. My psych professor, he had an operational definition of late for his then teenage son at the time. He said, "You are late if my alarm clock goes off before you get home." And so his son, what he had to do is he had to come into the house very quietly, sneak into his parents' bedroom, and turn off his dad's alarm clock. So that is a very good operational definition. If the alarm clock goes off, he is late. And everybody can agree on whether the alarm clock goes off.
Yeah, that's a good example. And the advantage of operational definitions is they eliminate ambiguity. And they have concrete definitions, but they have their problems.
That was inspiring.
Thank you. I'm really good at this.
Yeah, I can tell.
But yeah, they have their problems. They may be far removed from the construct of interest. For example, if you were to measure someone's intelligence by measuring their head circumference, that's a problem. You understand? That's a problem. Because the head circumference does not measure their intelligence. Okay? All right, any questions?
Why do you keep doing that?
Habit, I guess. All right, the other thing about operational definitions is they are extremely flexible. Okay? That is a problem. Okay, so you might say, well, that operational oh dear. Well, you might say that operational definition didn't work. So let's go ahead and try another. All right? Yeah, that's a problem.
Yeah. Oftentimes, flexibility in science can be a problem because you can bend the conditions to fit your research questions or hypotheses or whatever.
Exactly.
So the scientific method, this is scientific method. There's no really the scientific method. It's just kind of these socially constructed guidelines for how people think research ought to be conducted. And so I've kind of put it into 5 steps, I guess. So one thing that we could do, or the first thing we do, is we develop a theory to explain a phenomenon. Then subsequently we design an experiment, and hopefully the experiment is ideally suited to test the phenomenon. And what we might say is it's best to design what we call critical experiments. And what a critical experiment is it is a experiment designed to conclusively determine one hypothesis over another. So the rat T-maze example is an example of one. So the idea is you've got a T-maze, and the researcher puts food on the right side, for example, and the rat sniffs around and then eventually finds the food on the right side. And the scientist starts the trial again, and the idea is if behaviorism is the truth, the hypothesis, the reason all humans and animals behave the way they do, then what would the rat choose? Well, the rat would choose the right side. Now, what would an evolutionary psychologist say? Well, an evolutionary psychologist would say, well, the rat, built into their genes, they know that the food on the right side has already been taken. So it makes no sense to go on the right side. Instead, you go on the left side. And so here is an experiment where it can only have one of 2 outcomes. It's either going to go right or it's going to go left. And we call that a critical experiment. If it goes right, it supports behaviorism. If it goes left, it supports evolutionary psychologists. Guess where the rat went? I'll wait. The left. The left side. So that provided support for the anti-hypothesis, if that's a word, that rewards are the only reason people do what they do. So, again, develop a theory, explain a phenomenon, or develop a theory to explain a phenomenon. You design an experiment. Number 3, you formulate a hypothesis or a research question. Number 4, you measure the outcome, and this is where psychologists get stuck because it's really hard to measure things that are psychological. Like, how do you measure love? Number of songs that they listen to that use the word love. How long they hold hands with their partner. How many times they say, I love you. Problem is, there are some people who are madly in love and yet don't hold hands. Maybe it's not culturally acceptable to do that. Or maybe there is somebody who's in love and yet doesn't like sappy love songs. What do you do? That's the problem. And then number 5, we refine the theory and repeat. So those are the steps to scientific method. So I'm going to challenge you to go through the scientific method to explain a phenomenon. And the phenomenon is that we have loud, haunting noises in Bunce Hall. You ever heard this? Did you know that Bunce is haunted? Okay. And so we have 2 bits of data. We have loud, haunting noises. Okay, you got it? And then the second thing we have is we have translucent people sightings. Okay, so what your job is, oh, and by the way, it only seems to happen at night. So your job is, so these are the data that we're trying to explain. I want you to come up with a theory, come up with an experiment that will test your theory, come up with hypotheses, etc., and then report back to me. Go ahead. I'll wait. Okay, did you do it? Awesome. We will go ahead and talk about these in class, yo. All right, Dougie, you want to take this one?
Yeah, I guess. All right. I want everybody to stand up.
And why is that necessary?
It's my turn to talk now. Will you just let me talk?
Oh, sorry. You're the boss.
All right. I want everybody to stand up. All right. Hope you're all standing up. Okay. And then what I want you to do is I want you to raise your hands in the air. Okay. Just like this. Good. Good. Everybody. Good. Now I want you to say scientific method. All right. Say it. Scientific method. Say it with enthusiasm. Scientific method. All right. I think they got it.
Okay. Moving on. All right, so there are two major assumptions of the scientific method. This is according to Maxwell and Delaney. One is that nature is uniform or nature is consistent. It always behaves the same way and it always will.
Yeah, that's right. And that means we can actually discover its rules.
Very inspiring, Dougie.
Thank you.
All right, and the second assumption.
Oh, I'll take this. Is finite causation. Okay? We don't need to know. We do not need to reproduce the exact conditions for causal statements to be made. All right? For example, depression is caused by childhood trauma interacting with one's biology. All right, so what are the conditions here? Professor Fife, you want to answer this one?
Sure, yeah. So the conditions here are childhood trauma and biology. So we only need two things to explain depression. Childhood trauma and one's biology. And biology is loosely defined here. Versus...
Oh, I'll take this one. Depression is caused by childhood trauma interacting with biology, time of day, barometric pressure, relationship satisfaction, etc.
Yes, exactly. So the conditions to establish causality are finite. That's what finite causation means. In that second example, we've got a whole long list of things that cause depression. And that ... seems to indicate this is going to go on forever. Well, that's not a very helpful scientific model, is that there are an infinite number of conditions that we have to determine in order to explain what's going on. So basically, this is about interaction effects. There are a limited number of interaction effects going on. That's what finite causation means.
Yeah, exactly. All right? Interactions, yeah, none of them.
No, I didn't say none of them. I said there's a limited number.
Yeah, that's what I meant. Limited number of interactions.
Yeah, thank you.
You're welcome.
All right, so what are the goals of science?
Oh, I'll take this one. So according to your book, which is a very good book, mind you, I've read it, and I love it.
I'm sure you have. Do you remember the name of the author?
I read so many books, I can't keep them straight.
Yeah, I understand that. So according to your book...
Actually, can I take this one? Yeah, I want to take it. Oops, switch characters there. Okay, according to your book, the goals of science are description. So that means we want to describe things, okay? Prediction, which means we want to predict things. Explanation, which means we want to explain things. And application, which means we want to apply things. All right?
Yeah. And if anybody can think of any examples of those, let's talk about them more in class, or as they say.
Oh, I'll take this one. I know how this goes. Go ahead and leave a comment below, and we can have a discussion together. All right?
Good, thank you. But really, the purpose is to determine causation. So across each of those, we're really trying to tease out what is going on here. So how do we determine causation? Well, there are three conditions we must satisfy in order to determine causation. Covariation, which means the two variables vary together. There is a time-order relationship. So basically what that means is the thing that is doing the causing precedes the thing that is caused. And number 3, we eliminate plausible alternative causes. So the first two are pretty easy to establish, but the last one is kind of tricky. And so this gets us into the idea of confounds. So a confound is an alternative causal explanation. For example,
John is...
Did you want to talk, Dougie?
Yeah. John is researching mindfulness as a means of reducing stress. He has a group of participants think of a stressful event from their life and measures their blood pressure. Subsequently, the experimenter trains participants in mindfulness. Afterward, he has them again recall the experiment and finds their blood pressure is significantly reduced. All right, so what confounds do you see here? Think about it. All right.
Well, actually, how about we have a discussion about that, Dougie?
Oh, yeah, absolutely.
So, Dougie, what kind of confounds do you see here?
Oh, lots of them.
Great. Such as
there's going to be alternative causes here, because that's what a confound is.
Yeah. So, for example,
well, you know, I want to leave this one to you because you're so good at explaining these things.
Thanks, I guess. All right. So basically what we have people doing is they are thinking of the experience before and after doing mindfulness. But what you don't know is maybe their blood pressure is reduced just because of repeated exposure. They're now they're used to experiencing or cognitively thinking about that event. So it's just kind of a practice effect. So to hopefully tease that out, what you could do instead is you could randomly assign people to either be mindful or do something else. So that would be an example of a confound. Alice, no, I'm going to take this one.
All right.
Alice wants to determine whether personalized feedback improves academic performance. She has participants come into the lab and randomly assigns them to one of two conditions. In the first, they take an exam, perform crossword puzzles, then take the exam again. In the other group, they take the exam, the experimenter gives feedback and further instruction, then has them take the exam again. Alice finds much more improvement in the feedback condition and concludes that personalized feedback improves performance. So what confounds do you see here? Well, I think the confound that readily comes to mind is maybe it's not the fact that they are getting personalized feedback. Maybe it's the fact that they're getting attention. So they're having an opportunity to talk with an experimenter, which motivates them to try a little harder in the second round. Now you could argue, well, that's part of the feedback process, but it's probably not the feedback per se, it's the positive attention. So those are some examples of confounds. So wouldn't it be nice if we could somehow perform an experiment twice, but in between the first and the second experiment, if we could just erase their memory? And this is the idea behind the counterfactual model. And the counterfactual model gives a kind of more of a mathematical definition for causality. And it's a framework that a lot of psychologists find useful in trying to identify what causality means. So the counterfactual model states what would have happened had this person received the manipulation, or if they were in the manipulation condition if they had not received it. So for example, what would have happened to my GRE scores had I been raised in the inner city? Okay, I wasn't raised in the inner city, but what would have happened had that happened? Or you might ask, what would have happened to my income had I been homeschooled? I wasn't homeschooled. But it would be interesting to find out what would have happened had I been homeschooled. And these are substantive questions of interest. And so the mathematical definition of a causal effect is the difference between my score that I actually obtained as a non-inner city person who took the GRE and my GRE score had I been raised in the inner city. And likewise, the difference in my income had I been homeschooled versus now, that is what we call the causal effect. So how do we estimate that? Well, that's a problem. We can't. Instead, we find analogs of this to establish causality. Everyone okay? Oh, look at me. I'm asking questions now. Nerd. Anyway, so establishing causality. Well, the problem is we can't replay someone's life and assign them to some other condition. Instead, like I said, we try to find an analog. So is there someone else who is very similar to me that was homeschooled? And so what is the purpose of research methods? That's basically all this class is about. We're trying to establish causality here. Now, causality has become kind of a bad word in science. We don't like using the word causality, okay? Because we need to be careful about our assumptions, and we never say that A causes B. Well, why not? That's what we're trying to find out, right? So what we want to do is we want to find some way of equating two conditions, for example, experimental versus control, such that we can determine the effect of some intervention on the same person. Although, of necessity, we have to use two different people. Unless we're doing a repeated measures thing, but even then you have practice effects that you have to deal with. So, there is a experimental versus quasi-experimental distinction. Basically, in an experiment, what we do is we randomly assign people. We flip a coin and say, all right, if it's heads, you go in the experimental condition. If it's tails, you go in the control condition. And what happens is that random assignment, on average, that's an important word there, on average, will make the treatment and the control groups the same on all these characteristics that could muck up the relationship. Or in other words, my quote-unquote soulmate. That sounds kind of funky. Anyway, my soulmate on average, or the person, my identical twin, if you will, on average, will belong to the treatment group somewhere. Or the average of my group's characteristics will approximately equal the average of the experiment, or the other groups. Etc., etc., etc. Fumbling! All right, so I don't know, for example, what would have happened had I been in the control condition, but my soulmate or my identical twin knows. And we know me, and so we look at the difference between me and between that person. Okay? So in reality, we may not be able to match people like I'm talking about. If the sample is big enough, we just aggregate the two groups and compute the difference in means. So for example, the mean of the treatment group minus the mean of the control group is our very best approximation to the difference between me in the treatment group and me in the control group, as well as you in the treatment and you in the control, etc., etc., etc. Okay? So kind of a mind-bending way of thinking about it, but it turns out that that's a useful way of thinking about it. All right. With quasi-experiments, on the other hand, I'm sorry, Dougie Pete's poking me.
Yeah, I want to talk here. I got this one. I'm good at quasi-experiments.
By all means, Mr. Pete.
Right, so experimentation isn't always possible, right? You can't always experiment. So random assignment on average makes the two groups soulmate-like or like identical twins, all right? But sometimes the comparison groups are already intact. For example, you have Class A and Class B, or you have Portland in Seattle, or you have Therapist A and Therapist B.
And their clients.
Yeah, exactly. So the clients of Therapist A versus the client Therapist B.
And yeah, you can't randomly assign Therapist A clients to be with Therapist B clients, or Class A to be with Class B, or you can't randomly assign people to go to Portland or Seattle. So you have these intact groups.
Right. So, if I'm in Class A, you might ask, do I have a soulmate in Class B?
Or, for example, if you are in Portland, do you have a soulmate in Seattle? Well, it turns out that even though Portland and Seattle are geographically close to each other, people in Portland are just different than people in Seattle. Okay, there's kind of this community effect going on. And so the characteristics are natively different.
So yeah, back to confounds. This whole class is basically teaching you in your mind and in your heart how you might eliminate confounds from experiments. And that's why this class takes an entire semester. It turns out it's really hard unless you believe.
Actually, it really has nothing to do with belief.
Unless you have faith.
No, actually it has nothing to do with faith either.
Unless you try.
Getting there.
All right, turns out it's really hard to eliminate confounds. That's all I'm saying.
Great. Thank you, Dougie Pete. And so here's the activity. So last time in class, there's no video for this, I invited you to think of a topic you wanted to study and go to the literature and find out what the evidence is for or against a certain opinion. And now what I want you to do on your own is come up with a hypothesis and come up with different ways to test it. So you can do it using intuition and everyday methodology, like most people do. You could decide, in fact, I would encourage you to decide to use all of these. You could experiment in the lab, you could experiment in the field, or you can use observation without manipulation. So there's your activity.
And make sure that you try, and you believe, and you have faith. All right? And heart. And grit.
Very inspiring, Mr. Pete. Thank you.
You're welcome.
All right, so now we're going to talk about theory. So your book states that we need theory for 3 reasons. One is it organizes knowledge into kind of a systematic set of beliefs. It guides researchers into different areas of the theory that need a little more research, and it creates a framework under which we can understand a phenomenon of interest. So let's go ahead and name some theories in psychology.
The theory of love.
Don't think that's a theory.
All right, your turn.
Okay, thank you. So like cognitive psychology or behaviorism or cognitive behaviorism or psychodynamic or positive psychology or all sorts of these sorts of theories. So lots and lots of theories in psychology.
Yeah, which is awesome. We need lots of theories in psychology.
Actually, it's not so awesome. You weren't here last time. We talked about how not awesome that was.
Oh, right.
Now ask yourselves, which of these psychological theories have data to support them? And what do I mean by data? Well, what I mean is evidence that demonstrates the theory has merit. So, for example, Freud's theories are very, very elegant and very complex and very coherent, actually. But where's the data? What evidence do we have that there is such thing as an Oedipal complex?
What's an Oedipal complex?
Look it up. Wikipedia.
Oh, right, yeah.
Likewise, we can have data without theories. For example, the MMPI, at least in the first iteration of it, the MMPI, how they made the test was basically they came up with a bajillion questions and then administered those questions to lots and lots of people that were known in advance to have different forms of mental illness, depression, anxiety, schizophrenia, those sorts of things. And so what they did then was it was completely empirical and had nothing to do with theory. They found those items which discriminated best between those who were depressed and those who were not, and those who had schizophrenia and those who did not. And oftentimes the questions had absolutely no face validity, which we'll talk about in a minute. Like, do you read trucker magazines? I think was one of them. And somehow that differentiated between those who were schizophrenic and those who did not. No theory to back it up. But like I said a couple weeks ago, progress in science is defined as the degree to which theory and data become interconnected. And so here's a quote that I am quite fond of Richard Feynman, who is very critical of psychology. And he said,
In the South Seas...
Great. Yeah, that's right. You're very good at reading things, Dougie Pete. So go ahead and read this one.
All right, good. In the South Seas, there is a cargo cult of people. All right? During the war, they saw airplanes land with lots of good materials. And they want the same thing to happen now. So they've arranged to imitate things like runways, to put fires along the side of the runways, to make a wooden hut for a man to sit in with 2 wooden pieces on his head like headphones and bars of bamboo sticking out like antennas. He's the controller, and they wait for the airplanes to land. They're doing everything right. The form is perfect. It looks exactly the way it looked before. But it doesn't work. And why doesn't it work? Because they don't have faith.
There you go with that faith thing again. No, it has nothing to do with faith. So Richard Feynman was criticizing psychology for lacking a well-developed theory to accompany the data.
I could have read that.
I know you could, but yeah. So basically the idea is that these people were performing a ritual that they thought would bring airplanes. And likewise, he's saying of psychology in their attempt to copy physics in the use of the quote-unquote scientific method. It's the exact same thing. Just because you have the form of objectivity and mathematics and those sorts of things doesn't mean you're actually going to bring about real results. And so that was his criticism of psychology, for basically having a lack of theory to accompany the data or the method. So what is good science? As I've said before, good science is the marriage of theory and data. So theory informs a researcher about where to collect data, and often that means critical experiments such as the T-maze experiment, and data often informs researchers about how to refine their theories. So for example, there's a man by the name of Leverrier, a mathematician in the 17 or 1800s, can't remember, and basically what he was doing was he was looking at the current theory for the motion of planets, and the current theory, said, hey, look, Mercury, or I don't remember what planet it was, but Mercury should be right there. And he looked, and it was off, just slightly. And he said, wait a minute, the theory says Mercury should be right there, and yet Mercury's not right there. And so he did some adjustments and started saying, I wonder, the gravitational theory says it should be right there, but it's not right there. It's off a little bit. I wonder if there is another body close by that has a large gravitational pull that is pulling Mercury off of the trajectory that the existing theory says should happen. And so what does he do? He pulls out his telescope, looks exactly where the theory predicts the mass body should be, and lo and behold, there's Neptune. So again, this is an interesting situation where the data wasn't quite working, and so an adjustment to the theory had to be made, and that led to the discovery of Neptune. That's just fascinating. That right there is good science. Again, linking theory and data.
So let's talk about Popper. All right, good name, Popper. He's a poppy philosopher.
What is that even supposed to mean?
Give me a minute here. He's poppy. He's peppy.
Those are not the same word.
I know. All right. Anyway, Karl Popper was an influential philosopher who philosophized about things and had theories and stuff in the 20th century. So Popper noted that you can never prove a theory conclusively unless you...
No, it has nothing to do with faith.
I wasn't going to say that. I said unless you have proof. So stop interrupting.
Well, I think the point is that you can't prove something.
Yeah, which is what I was going to say.
Okay.
So your theory might state, for example, that all swans are white. But we will never know for certain if this is ever true. All right? Because what it would do is it would require collecting all swans who currently live or who will ever live. And that is clearly impossible. On the other hand, a single occurrence of a black swan, for example, will disprove the theory. All right? And so the idea here is, Professor Fife?
Yeah, so the idea is that you can never prove something, but one counterexample can disprove something. And so Karl Popper advocated for scientists to attempt to disprove their theories. And the longer a theory remains disproven, then the stronger the merits of that theory.
Right.
So how does one best theorize? Well, because a theory can never be proven right, we instead ought to spend our efforts proving a theory is wrong, just as Karl Popper suggested. And so the longer the theory withstands these tests of falsification, as Popper called them, the higher the probability the theory is true. And we do this by designing critical experiments where if the experiment comes out one way, it conclusively proves that theory is false. And critical experiments, so more about critical experiments. They have concrete hypotheses that support the merits of one versus another hypothesis. So let's think about Maslow's theory. Could it be falsified? Well, let's think about it. His theory says that there's a hierarchy of needs, that we must first satisfy physiological, then safety, then love and belonging, then esteem, and then eventually self-actualization. And so his theory very strongly states, which is actually a strength of the theory, is it provides a very falsifiable statement. So Maslow says you must satisfy the lower needs before you satisfy the upper needs. So if you were ever to find a situation where somebody's safety is threatened, there should never be an attempt by that person to seek love and belonging. And there have been repeated examples where the hierarchy doesn't quite stack up to what the data say. So what about behaviorism? Is there a way that we could falsify this? Well, again, this requires making strong statements. Back in the day, behaviorism, as I understand it, did make strong statements such that all human behavior is based on rewards and punishments. And there have been multiple experiments that, quote unquote, prove that is not the case. That there are situations where people aren't guided by punishments and reinforcements, but by genetics or some other motivating force. Since then, behaviorism has been refined quite a bit to say that, well, to recognize that, well, certainly people have other motivations, certainly genetics and instinct play a role, but predominantly it's behaviorism, or predominantly it's rewards and punishments. And so anyway, we could talk more about this in class, about how to identify or how to make a prediction that would conclusively refute behaviorism. And the problem, anyway, we'll get to that later. So how about evolution? Is there a way, is there some bit of evidence that we could find that could conclusively put a nail in the coffin on evolution? And that's what I was going to say about behaviorism. Both behaviorism and evolution in their state now, they're really hard to falsify because they're really flexible. If you think about evolution, and you think about a characteristic that seems counterintuitive, that it would be adaptive for some reason, if you're good enough in thinking about evolution, you can find a way that something is adaptive. Does that make sense? So even though evolution is a beautiful and elegant and excellent theory, one of its weaknesses is that it is so flexible that it's really hard to falsify. All right, so that is all for today. Let's go ahead and give a round of applause for Dougie Pete.
Thank you. Thank you. Thank you.
You have been very inspiring today.
Yes, thank you. Remember, if you want to hire me for your corporate events or for your religious events or for your children's birthday parties, give me a call or shoot me an email. I'm on your side. Remember, believe in yourself.
Yes, that is probably the most important take-home message from today. Believe in yourself. Goodbye.